So students, now let's start activity 9.1, equation of family of lines passing through the point of intersection of two lines. So our objective for this activity is to verify that the equation of line passing through the point of intersection of two lines, that is a1x plus b1y plus c1 equals to 0, and the other line a2x plus b2y plus c2 equals to 0 is a1x plus b1y plus c1 plus lambda into a2x plus b2y plus c2 equals to 0. So students, now let's start the method of construction for the given activity. Step 1. Take a drawing board and fix a graph paper on it. Draw two perpendicular lines intersecting at O such that x dash OX is x-axis and YOY dash is y-axis and O is the origin. Step 3. Draw the graph of the given two lines and note down their point of intersection. So students, this is the point where the two lines are intersecting, that is a1x plus b1y plus c1 equals to 0, and the line a2x plus b2y plus c2 equals to 0, that is the intersection point is P. So students, now let's see the demonstration for the given activity. Let the equation of a line be 2x minus 5y minus 10 equals to 0 and 3x plus 5y minus 15 equals to 0. So these are the two equations of line. Now let's construct a table for the values x and y for the first equation, that is 2x minus 5y minus 10 equals to 0. So the table 1 for 2x minus 5y minus 10 equals to 0. So now we'll let the value of x and find the value of y. So first let's take the value of x 0. So when we put x equals to 0 in the given equation, we get y equals to minus 2. Now when we put the value of x equals to 5, then y is 0. So when put 5 in place of x in the given equation, we get y equals to 0. Similarly, table 2 for the equation 3x plus 5y minus 15 equals to 0. So let's construct the table. Now let's let the value of x. Now let's put the value of x 0. Then y is 3. We get y equals to 3. On solving, let me show you how to solve. 3x plus 5y minus 15 equals to 0. Now x is 0, so 3 into 0 plus 5y minus 15 equals to 0. Now 5y, 3 into 0 is 0, so 5y equals to 15 and y equals to 3. Similarly, when we put x equals to 5, then y is 0. Now, draw the graph of the two lines using the values given in table 1 and 2. Table 1 and table 2. So students, this is the graph of the two lines intersecting at a point P where the coordinates is 5, 0. So this is the line 2x minus 5y minus 10 according to table 1. We have plotted the coordinates 0, minus 2 and 5, 0. And in line 2, that is 3x plus 5y minus 15 equals to 0. The values of x and y according to table 2 is 0, 3 and 5, 0. And they intersect at the point P, that is 5, 0. So the two lines intersect at a point P 5, 0. That is the coordinates of point P. Step 3. So the equation of the line, so the equation of the line passing through the point of intersection P 5, 0 of two lines that is 2x minus 5y minus 10 equals to 0 and 3x plus 5y minus 15 equals to 0 is given by so the equation of line passing through the point of intersection P of two lines 2x minus 5y minus 10 equals to 0 and 3x plus 5y minus 15 equals to 0 is given by 2x minus 5y minus 10 plus lambda 3x plus 5y minus 15 equals to 0. So students, now take lambda equals to 1, minus 1, 2 and 1 by 2. So in point 4, we'll take lambda equals to 1, minus 1, 2 and 4. We'll put the values of lambda 1, minus 1, 2 and minus 2 in 4 different cases. First, put lambda equals to 1 in 2x minus 5y minus 10 plus lambda 3x plus 5y minus 15 equals to 0. So we get 2x minus 5y minus 10 plus 3x plus 5y minus 15 equals to 0. So 5x minus 25 equals to 0, and x, taking 5 common, we get x minus 5 equals to 0. So the equation x minus 5 equals to 0 is satisfied by the point of intersection P 5, 0. So when we put x equals to 5 in the given equation, we get 0 equals to 0. Hence, at lambda equals to 1, our equation is satisfied. Now, we take lambda equals to minus 1 and put it in the equation 2x minus 5y minus 10 plus lambda 3x plus 5y minus 15 equals to 0. So now put the value of lambda equals to minus 1, 2x minus 5y minus 10 plus minus 1 into 3x plus 5y minus 15 equals to 0. So 2x minus 5y minus 10, and when we multiply minus 1, it becomes minus 3x minus 5y plus 15 equals to 0. Now minus x plus 10y plus 5 equals to 0. So minus x plus 10y equals to minus 5, x minus 10y equals to 5. Now put point value for point P, x and y at P 5, 0. So it becomes x is 5, 5 minus 10 into 0 equals to 5. So 5 equals to 5. Hence the equation x plus 10y equals to 5 is satisfied at point P 5, 0. That is the point of intersection P 5, 0. Now put lambda equals to 2. That is 2x minus 5y minus 10 equals plus lambda 3x plus 5y minus 15 equals to 0. Now let's put the value of lambda equals to 2. 2x minus 5y minus 10 plus 2 multiplied by 3x plus 5y minus 15 equals to 0 equals to 2x minus 5y minus 10 plus 6x plus 10y minus 30 equals to 0. So it becomes 8x plus 5y minus 40 equals to 0. So we get 8x plus 5y minus 40 equals to 0. Now put point P 5, 0 in 8x plus 5y minus 40 equals to 0. Now put the value of x and y. We get 8 into 5 plus 5 into 0, that's y 0 minus 40 equals to 0. So 40 minus 40 equals to 0. So we get LHS equals to RHS, that is 0 equals to 0. Hence, the equation eight x plus 5y minus 40 equals to 0 is satisfied at point P5, 0. That is the point of intersection, point P. Step 8. Now put lambda equals to 1 by 2. So we have 2x minus 5y minus 10 plus lambda 3x plus 5y minus 15 equals to 0. So now let's put lambda equals to 1 by 2. 2x minus 5y minus 10 plus 1 upon 2 3x plus 5y minus 15 equals to 0. So 2x minus 5y minus 10 plus 3x plus 5y minus 15 upon 2. Now take the LCM 2, we get 4x minus 10y minus 20 plus 3x plus 5y minus 15 equals to 0. So we get 4x minus 10y minus 20 plus 3x plus 5y minus 15 equals to 0. So 7x minus 5y minus 35 equals to 0. Now put point P 5, 0, that is the value of x and y as 5 and 0 in the given equation. We get 7 into 5 minus 5 into 0 minus 35 equals to 0. So 35 minus 35 equals to 0. So 0 equals to 0. So the equation seven x minus 5y minus 35 equals to 0 is satisfied by the point of intersection P5, 0. So the equation 7x minus 5y minus 35 equals to 0 is satisfied by the point of intersection P, that is 5, 0.